All right, good afternoon, ladies and gentlemen, and a very warm welcome to the thirdly best session of this conference, which is the panel discussion on 5G for vertical industries. So there are still not so many people in the room yet, but I think this will change, or I hope this will change shortly, and at least the most important people are already here, so that's why we want to start right away anyway. So my name is Andreas Müller. I'm from the Corporate Research Department of Bosch in Stuttgart, in the beautiful southwest of Germany, and I have the honor to chair this panel discussion today. So we at Bosch are actually highly engaged in quite a number of different vertical industries, and that's why the topic 5G is also for us getting increasingly important. And it's simply because 5G has the potential to enable a wide variety of new use cases and applications. And since the huge number of devices that may be interconnected by 5G in future simply represents incredible business opportunities. So the big money that comes along with 5G is, in my opinion, actually not in supporting 4K or even 8K video. It's not in enabling the next WhatsApp, WeChat, or Instagram. But the big money that comes along with 5G is in the creation of a very versatile, flexible, scalable, and powerful connectivity infrastructure for different vertical industries. And that's what we would like to discuss a little bit today. So we want to explore the challenges and opportunities that come along with 5G from the perspective of different vertical industries. And we want to bring both worlds a little bit closer together. So on the one hand, the traditional telecom world, and on the other hand, the vertical industries as represented in the panel here. So before I start to introduce the panelists to you, let me just give you a slightly more detailed introduction into the topic. So if we are talking about vertical industries in the context of 5G, we are essentially talking about the Internet of Things applied to different domains, such as the ones that you can see here, be it industry, transportation, energy, cities and homes, life and health, or traditional enterprises. And in all these domains, and there's certainly many more, there's currently this trend that more and more devices are interconnected with each other, sensors, actuators, and all kinds of other devices, in order to form so-called cyber-physical systems. And these cyber-physical systems, again, build a basis for the Internet of Things and for innovative new applications and use cases. And 5G simply has the potential to become one of the key technologies for realizing this ubiquitous connectivity between all these devices. However, this is only possible if we consider new frontiers in the development of 5G. And I guess all of you are well aware of that. So traditionally, mobile networks, at least in case of 3G and 4G, have been optimized towards mobile broadband, and this trend will go on in case of 5G as well. But in addition to that, there has to be the strong focus on machine-type communication. So on the one hand, massive machine-type communication, so that we can integrate a large number of different devices, small sensors, actuators, and so on. And to give a little bit more concrete example, what such a device could be, you can see here an asparagus sensor, which is offered by Bosch. So it can be used for monitoring the growth of asparagus. So a very simple, tiny application. Currently, it's connected to the outside world using Wi-Fi, but in future, it may be 5G as well, at least if you're doing a good job. And of course, here, we don't have to support data rates in the order of gigabits per second or even more. So what is more important is a very high energy efficiency, so that these sensors can be driven by battery, or that we can use energy harvesting. And it's very cost sensitive, so that we can deploy not only a single sensor per field, but maybe hundreds of sensors. And this is only possible if we have an acceptable price point. On the other hand, we also have to support ultra-reliable, low-latency communication. And this is especially required for all these control use cases, for example, in the automotive domain, to enable a tight platooning of cars. And we will certainly hear more about this in one of the follow-up presentations. But we also need it for many different applications in industry. So to make it a little bit more concrete again, you can see here another possible use case. This is a mobile robot, and what a coincidence, it's again a Bosch robot. This mobile robot is mobile in the sense that you can take it with you and use it at different places in a flexible manner for all kinds of joining, inspection, and handling tasks, and so on. And currently, it's self-contained. That means all the control, all the processing, the energy supply is contained in this box here. And what we would like to do in future, if we're able to do that, is to move this intelligence to the network so that the robot itself is relatively stupid and all the intelligence is in the network, which comes along with several benefits. And this is, of course, only possible if we have an ultra-reliable low-latency communication, if we have concepts like edge computing and things like that. So all these building blocks that are currently considered in the 5G context. So and here we're really talking for several applications of latencies in the order of 1 millisecond or even below. We are talking about ultra-high reliability, packet error rates in the order of 10 to the minus 8 and even smaller. So for all these fancy numbers, we have the right use cases that need them. So this is the vision behind 5G, and it still remains to be shown that 5G can keep the promises that are currently being made. But if it's possible to keep those promises, then of course there will be numerous opportunities that we can obtain. So I already mentioned before, so 5G for us is in general an enabler for the Internet of Things and Services. And thereby it's also an enabler for an unprecedented degree of automation and comfort in many different domains. At the same time, we can also enable new business models. So business models requiring some sort of connectivity. So just to put it, or make it a little bit more concrete again, you can think of a company like Bosch or ABB, which are currently selling robots, for example. And in the future, we may not sell the robot, but we may sell the robot as a service. So that means the customer doesn't pay a one-time fee and then owns the robot, but we put the robot there, and then the customer simply pays for what he needs, for how he uses the robot. So depending on the time that he uses it, depending on the number of movements of the arm, and so on. And this is only possible if we have permanent connectivity to the robot. Also, 5G may be an enabler for big data analytics. So if we have all these sensors connected via 5G, we can collect a lot of sensor data and then make something good out of it. With many applications in the healthcare domain, for example, but also in industry for condition monitoring, predictive maintenance, so that we can predict before a certain machine fails or gets damaged. And last but not least, there are also opportunities, of course, for the telecom industry, simply to sell more devices, to generate more traffic, and thus generate more revenue. So these are just some selected opportunities that we see, but as always in life, there are also some challenges that we have to face. For example, in the past, there was basically one use case in mobile networks, namely to connect a mobile device, a smartphone, a laptop, to the network, to the internet. Now with the vertical industries coming into play, we suddenly have countless different use cases. And that simply adds complexity to the whole topic, especially because each use case comes along with its own requirements. So in the past, we had several very few requirements, like higher data rates, lower costs. These were basically the two most important points. Now with these new use cases coming up, we certainly have very diverse requirements depending on the use case that we consider, with different latency, security, safety, energy efficiency requirements, and so on. So it's simply getting much more complex. Also in the past, the business model was relatively clear. So network vendors sold equipment to network operators. Network operators operated the network and offered a service to the end user, which in most cases is either you or me. Now with the vertical industries, also this will change dramatically because we will have a new ecosystem. So it remains to be shown if a data plan for a smartphone is the right billing model for an asparagus sensor, or maybe we need some new ideas how to charge for that. And also the vertical industries maybe do not really want the operator to take control of everything. So if we think of a private 5G network, for example, in a factory, at least I can tell this for Bosch, so then we are very hesitant to let the operator in and operate a network in our plants. And last but not least, it's really important to establish a common language between the telecom industry and the vertical industries. So I think sometimes we are using the same terms, for example, latency, but we refer to different things, we have different things in mind, because if you talk to someone from industrial automation and talk with him about latency, he might have a different understanding of latency compared to someone from the telecom industry. And therefore, it's, as I said, it's important to interact, to collaborate with each other in order to make sure that 5G really will become a success for vertical industries. And that's a little bit what we would like to achieve today with a panel discussion. And if you're not convinced yet, so here's an overview of good reasons to stay in this room and to join the panel discussion until the end. So we'll learn a little bit about use cases and requirements from the perspective of different vertical industries. So it's not someone telling what verticals want, it's the verticals themselves telling what they need. We will also discuss key technologies for making these use cases reality. We will talk about business aspects and ecosystems, new ecosystems that are required, new collaboration models. We will also discuss a little bit about alternative solutions. So certainly 5G will be the best technology that we can imagine, but still there are some other alternatives out there, and for every use case, basically, we have to decide which one is the right one and which one not. And last but not least, we have comfortable chairs in this room, so if you just want to settle back and relax a bit, it's fine as well, as long as you don't make so much noise and disturb the others. All right, so but that's it for the short introduction. And now it's really my big pleasure to introduce the different panelists to you. So, yeah, you can see the names here. We have Linus Dryboom from ABB in Sweden. Maybe you can just raise your hand, Linus. Thank you. So ABB, of course, is a very strong player in the areas of industry and energy, and also building automation. Then we have François Fischer from Ertico in Belgium. Ertico being one of the leading organizations dealing with intelligent transportation systems. We have Johannes Riedel from Siemens in Germany. And I think I don't have to say much about Siemens here, a leading player also in industry and energy. We have Christoph Tümmler from Napier University in Edinburgh in the UK, one of the pioneers in e-health. And if you feel uncomfortable because of the warm weather today, Christoph is the right person to approach since he's a real doctor, not just an engineering doctor. And last but not least, we have Ioannis Koglioros from OTE in Greece. So he's representing the perspective of a network operator on the panel. So the plan is as follows. We will have brief introductory presentations by each panelist, at most 10 minutes. So presenting the point of view and use cases, requirements. And afterwards, we will then enter in a more interactive discussion. And then, of course, everybody in the audience is kindly invited to join the discussion and to ask questions that you always wanted to ask. Some of the verticals, you can give comments to whatever you want to comment on. And I really hope that it will be a very interactive discussion then. All right, but now, yeah, we start with the first presentation, and this will be given by Linus Dryboom from ABB. Linus is the manager of the industrial IoT team at ABB Corporate Research in Sweden. He joined ABB Corporate Research in 2008, where he was working as a principal scientist and project manager in the area of industrial communication, including 5G, time-critical Ethernet, time synchronization, positioning, and many other exciting topics. He led the preparation of the 5G PPP white paper on energy and 5G, and his background is in computer science. He got a Master of Science degree in computer science from Chalmers University of Technology in Sweden in 1991. So it's nice to have you on the panel, Linus, and the floor is up to you.
Thank you, Andreas, for a nice introduction and presentation. I think you made an excellent start of this presentation panel. I'll try to do my best. So I will give you first a quick introduction to my vertical, and then some questions, topics for the discussions later on. Maybe we can trigger you a little bit. Oops. So I'm from ABB, a global company in power and automation. We are focusing on, as I said, power and automation. Our customers are in utilities, water, energy, waste, etc., industry, different types of processes, factories, as well as transport and infrastructure. We are global, all around the world, 135,000 employees, roughly. And to give some more input on our application domains, we are working in power generation. It could be renewables, it could be fossil power plants, creating power. It's also about energy distribution, transmission power, managing the network, substations. We have the industry automation with the processes, constant flow of chemicals or paper, steel. Factory automation, where you are manufacturing maybe cars with robots. We have the building automation, large commercial buildings as well as private homes. Some nicer pictures to that. And then we are going into a little bit on the 5G topics that we'll talk about today. My favorite use case here on 5G is on the smart grid. So looking into what you can do with the protection, control and monitoring in the distribution of power, I think that's a good fit with 5G. What's happening is that we are adding lots of renewables, electrical vehicles, storage, etc. And this needs to be protected, controlled, and also monitored. And even if this can be done with one infrastructure like 5G, it would be a very good fit, I think. I also challenged myself to pick some other use cases, and in process automation, for example, mining or crane systems could be such one. Here, our customers would like to put people more away from the real process, take them to a safer environment. Also, common for these applications is that they are going into more and more autonomous production. Also here, 5G can help with positioning and communication. Stretching a little bit more, other domains would be maybe to integrate existing wireless technologies we have in the plants already today and creating something like close like a wireless plant. Also building and home automation, I think, is a good opportunity for 5G, thinking of that people, consumers will bring lots of 5G equipment home. There is, of course, an opportunity for 5G there as well. Requirements and challenges. Up to the left, typical technical requirements for our domain are listed here. Creating a very robust communication system which should deliver data on time. And on time means really on time. Maybe one packet out of 10,000 or one packet out of 100,000 is allowed to come too late, but all the others should come on time. So robust communication together with positioning and time synchronization, which are accurate, is what typically is needed for our applications. Also, our environment can sometimes be harsh. We also need it to be manageable by people in an efficient way. Here is an interesting topic with your mixing unlicensed, licensed spectrums that was also addressed this morning. I think that could be a challenge. Also, liability is important for us. So it's very, very expensive if there is a blackout or a production stop in our process plants, and not someone needs to have to pay for that. Successful steps for a failure, or something like this. Steps for failure, at least. So what can we do to really fail? I think the first one is to think that we can continue to use the same business model as today. That would be a very simple way to fail. Another one is what I mentioned before, to mix worst case latency with average latency. My industry, we always think about latency as the worst case latency. That's because we need to define or define our applications based on that, the worst case. Also, to avoid using the KISS rule, the keep it simple rule, and instead end up with a very complicated and expensive system would also be a good way to failure here. Okay, this is my last one. I'm usually quite optimistic. I also learned to be aim high to get out high, so that's why I put two slightly tough points here. But in 2020, I think that 5G will be the common solution for modern mines, as well as be deployed in many smart grid installations. We will see. Thank you.
Well, thank you very much, Linus, for this short introduction. And it's nice to see that ABB has a very similar view on the topic as we at Bosch. So could also, I mean, if we exchange the logo, then it could also be a presentation from Bosch, I would say. All right, so then we move on to the second presentation. The second talk will be given by François Fischer from Erdico in Belgium. François is a senior activity manager at Erdico and is currently involved in different European projects dealing with cooperative systems, emergency call, advanced driver assistance systems, and automated and connected driving. He's presenting Erdico at CEN and ETSI, as well as the Alliance for Internet of Things Innovation and the 5G PPP. And he's a senior expert in general in software development and telecommunications with a particular focus on standardization, compliance testing, and certification, and he joined Erdico in 2011. So thank you very much also to you, François, for coming, and we are very looking forward to your presentation.
Thank you for the kind introduction. Actually, I will mainly present two set of results concerning automotive and 5G. Some results coming out of the 5G PPP work to draft a white paper on automotive, and some Erdico investigation on cooperative ITS. There are numerous key drivers for automotive. So first of all, automotive is one aspect. We shall understand beyond automotive mobility. So there are now trends to create mass mobility as a service, where vehicles are becoming part of a very flexible network to offer door-to-door and very efficient services. In this key driver, one is, for the time being, the main focus of the automotive industry, but also communication industry. This is automated driving. So currently, the product, there are already some product on the market, and in the next year we will have more and more product on the market. These are autonomous vehicles, meaning they are not communicating. That's why we name them autonomous vehicle. But in the next future, we will speak about connected and automated vehicle, meaning that to push the level of automation, we will need connectivity. There are other services using connectivity, road and traffic information. One important sector for transport, which is transport and logistics, so the transport of goods, of people. And there are in this segment a lot of, how to say, improvement, a lot of efficiency to be gained with connectivity, knowing that, for instance, 40% of trucks are driving empty. One interesting project for a long-term future is a physical internet, where the smallest parcel will be considered as an IP packet and will be offered a very flexible and efficient way to be moved from one point to the other point. And last but not least, information society on the road will be very important for the future. In all next generation vehicle, connectivity will be provided with Wi-Fi. And of course, as vehicles are becoming automated, even the driver, when he's alone in his vehicle, will be out of the loop and will have a need of connectivity. So connectivity and IoT is definitely considered as being an essential ingredient for mobility innovation. During the drafting of the 5G PPP white paper, some KPI have been considered for the automotive vertical, because it's important to understand one can bring 5G compared to 4G for the automotive, and also to shape the next 5G network accordingly to the automotive needs. So you know that hundreds of millions of vehicles are driving every day in Europe, and I think the market of vehicles is something like 20 million new vehicles per year. However, the difference with the smartphone industry is about the life cycle. So a life cycle of a vehicle is around 10 years compared to 3 years for a smartphone. So we need to have a sustainable deployment of networks and technology. Some figures have been calculated. In particular, latency is seen as one key point for automated driving. Further to this KPI, there are also some global challenge from the car industry concerning the KPI. And the quality of service is very important. There is a need of sustainable and very fixed quality of service. Yeah. For instance, the latencies, they need to be stable. They cannot vary. And there is a need of prediction of the 5G network characteristic, so that if in 10 kilometers you know that the network capability are not sufficient for autonomous driving, you have, for instance, the possibility to find another way. So all these aspects are very new for the communication industry, because current mobile network have not been designed for safety application, and driving is a safety application. Out of this white paper and Ertico work, there are already some findings. For instance, one important issue is the availability. So the coverage of the connectivity should be everywhere, even in zone where no inhabitants are living, so where it is supposed to have no connectivity for the population. Ertico has analyzed in a report the different communication technology, and it has been established that these different technology currently, broadcast, ITS G5, cellular, SATCOM, etc., have all their specific characteristics and are all necessary under different contexts. So there will be a need with a 5G network to be able to connect all these different radio access. Yeah. Currently, CITS corridor, named Cooperative ITS Corridor project, are run in Europe. So almost all European countries are trying connectivity for vehicle. And hybrid solutions are foreseen. ITS G5 and LTE V2X will certainly be implemented in the next generation of vehicle. And these two technologies need also to be connected to the next 5G network. Connectivity is expected to improve reliability by redundancy and also to push the limit of the automation level. There is an important remark concerning network slicing, because it is really assumed that network slicing will be very important for connected and automated driving to offer the industry, in particular the car manufacturing industry, the right network operation conditions. That's a slide, I would say, which is not really necessary in this room, but you have to understand that the automotive industry is not very expert in telecommunication. So the automotive industry see 5G as a new generation of technology which make 4G, 3G and others completely obsolete. So, and there is a need to make it clear that 5G is not about a new radio access technology, but also a network including different access technology. So the vision in 2022, first of all, 5G will enable the deployment of a pervasive network. It's very important to have connectivity everywhere, high performance, mobile connectivity. Make possible also the short deployment of hybrid solution. Why? Because this hybrid solution will be integrated in the next 5G network. For the time being, the investment from public authority is blocked because people don't know what is the future technology. That's a problem of the pace of IT technology compared to the pace of automotive technology, and will be a catalyst for innovation in automotive. So it is seen that in automotive or in mobility, connectivity will be key. And certainly allow pushing the level of automation from the current autonomous vehicle relying on internal sensor to autonomous and automated connected vehicle having a very long vision, having the perception of environment through connectivity over pedestrian, over vulnerable road user and other vehicle. But we have seen either during the 5GPP work on the draft and our current project on automated driving that it's still not obvious which are the key performance indicators, which are the capability we need for the automotive, and research is still necessary to move forward in this direction. Thank you very much.
Well, thank you, François, for this interesting talk. So now we've seen for the first time some concrete numbers on the slides. As mentioned before, so we can take questions afterwards. First of all, we will end up with the individual presentations. And we will now move on to the next one, which will be given by Johannes Riedel from Siemens in Germany. Johannes received a PhD in mathematics in Munich in 2001. Afterwards, he joined Siemens, at that time Siemens Information and Communication Networks, as an R&D engineer. And since 2005, he has been leading the research group Industrial Networks, focusing on wireline communication network technologies for industrial control networks. Since 2008, he has been representing Siemens at the European level in the future internet context, and now also in the area of 5G. So also, thank you very much for coming, Johannes, and the floor is up to you.
Okay, thank you very much. So Linus already mentioned that 5G is expected to play an important role in the area of smart grid, and I'd like to take this example and get a little bit deeper in specific application areas to explain why and where this is really the case, and also give you some kind of numbers which kind of requirements need to be fulfilled. To be able to explain this, I need to go a step back and give you a short overview on what the communication network for smart grids look like and which kind of communication domains are really existing and should be taken care of. Now, in this picture, what you see is on the left-hand side the power network structure. It's quite simple, so to say. You have a low voltage, you have a medium voltage level, which is a couple of 10,000 volts typically. You have a secondary substation in between. So that's the little boxes along the roads, for example. Now, in a similar way, you have the medium voltage and the high voltage transformation, now getting much larger areas for this transforming as such. And then maybe you also have some extra high voltage area on the level on top. Now, if you put to the right-hand side, really, which kind of communication networks are we seeing today, what we have today already, what will play a major role, this is shown on with all the different bubbles, what you can see there, and you can see it's quite a lot. So very shortly, starting with the customer premises networks, then there is a communication network connecting, for example, the smart meters all to the secondary substation, which is assigned to it. Then within the secondary substation boxes, there is some local area networks. Then there are some wind parks, solar parks attached to the system, which also have their control networks. So it's continued in that way, that also the secondary substations amongst each other have to be connected via communication network, as well as the control centers, and so on and so on. So this is what you can see over the different levels. And for each and every of these different domains, there is a need to identify which kind of communication technology to use, and especially to choose that in a way that it fulfills the requirements what we have in these areas. And coming to the numbers I promised before, if you do some analysis on the applications, on the smart grid applications, which are running especially in the area through this backbone network connecting these large primary substations, then the backhaul network connecting the secondary substation, and then the access networks, you come roughly really to these kind of estimations. And let me go through that very shortly. Concerning the bandwidth viewpoint on the high voltage level and extra high voltage level, you typically have a quite high bandwidth, not because of this critical control traffic typically, but more because of video supervision, which is taking place quite a lot there. But the control applications running on this level, they put significant pressure on these latency values. So there we see a need for 5 milliseconds latency end to end, and please keep in mind that we are talking about areas which have a diameter of a couple of 100 kilometers, and that means most of these 5 milliseconds will already be taken by the propagation delay only. Then availability is very high. Nobody of us really wants to have such a big primary substation being exploding. That's not really funny. Therefore, of course, failure convergence time is very important. So there we especially need a behavior of the network that in case of a single failure at least, there is no loss of information. So we are not allowing any kind of outage there. That only can be done by multiple times sending the data and the information to the network, and therefore the network needs to be prepared for that. And battery backup is of course also always a topic to protect against power outages and to be able, after a power outage, to really come back into operation again. Now if you go to the medium voltage level, more on the backhaul side, so there it's much more relaxed. So we are talking about a couple of megabits per second per secondary substation. We are talking about 50 milliseconds latency, about 4 nines concerning the availability and failure convergence time. Now failures are allowed in principle. That means we can have a small outage, but we definitely should be less than a second. And if you go down to the access network area, there it's most relaxed, and looking into the smart meter application as such. So from a requirements viewpoint, that's not so hard to fulfill. So there we are in the kilobit per second range per customer. Latency about a second is not a problem at all, and also availability of 2 nines is still fine, and failure convergence time is not really mattering so much. Could be in the area of 1 second again, but is not really critical. Now, if you look into where 5G really could play and should play a major role in that field, also especially looking into these requirements, that's clearly in the area of this backhaul network. Also because their connectivity today is not easy to get. It's in many cases rural areas, so therefore coverage is playing a major role. And also the requirements are in an area which seem to be quite suitable to be addressed even on a short to midterm basis. Now, especially on this backhaul network, let me just show how such an application could look like. And this is what I show you here. This is a so-called fault localization, isolation, and restoration application. So that means the medium voltage network that is typically a ring. So this is simply this ring, which is built on the left-hand side by connections to 2 primary substations, and there are a couple of secondary substations which are marked with RMU here. And what's really necessary is within that ring kind of a connectivity, a communication network in between, which allows all these different secondary substations to exchange some data, as well as to exchange some data with a control center. And how this is operated is simply that, of course, you need to avoid loops. Therefore, there is a so-called normally open point, which is an open switch. And whenever there is a fault somewhere in the network, obviously, due to energy technology, there is a shutdown of the whole ring as such. But what we need to achieve, what we want to achieve, is kind of identifying automatically where this fault really happened, isolating that fault, and turning up the system again so that at least in that area where the fault did not occur can run again, and we again have power. And for this kind of process, for this kind of automation, what is done manually today, we really need sophisticated communication networks. Now, I mentioned the numbers on the slide, on 2 slides before. Now, what is really critical in that area, it's all about service guarantees, and this is one of the major differences when comparing telco requirements or common broadband requirements with the requirements from vertical side. Also, the previous talkers have indicated that one. It's not sufficient to put some emphasis or main emphasis on average values. We really need to have guarantees, and in many cases, also sharp guarantees. And the main parameters, I think that's quite in common also what has been said already. So real-time capability, as I have presented. Of course, we also need to have also a look into cost efficiency, because so the services as such, when provided through a 5G network, that should be on a competitive price compared to a situation where the operator of such a grid has to build its own network. Now security definitely is a topic. I mentioned about this black start capability, so being able to handle situations where you had a power outage and you have to turn on the system again. And definitely, since it's all about the guarantees, as I said, there needs to be means from a technical and from a business basis to do suitable SLA monitoring and management. So the consumer, the business consumer, the smart grid operator needs to be sure that his requirements, what he was requesting, are really fulfilled. And of course also the network service operator, he needs to be able to verify whether his network did his job correctly and the SLA has been fulfilled. And finally, also provisioning times is a topic. The more remote services are coming into the game, the more important it is to spontaneously or more or less spontaneously establish connectivity into these networks, into the smart grids, also considering the quality of service which is required for the specific remote services. And if you look into what is really deployed today and what you really can get today, none of these things really can be fulfilled suitable. And therefore, I think it's a major task of 5G to really lay the technical basis for addressing these kind of requirements. Now, what can or could really go wrong if we do things not in the right way? So there, I think it's really three major points. First major mistake we could really do is to not exchange in deep detail with the vertical players, because I think mutual understanding is really key there. And also, as it has been mentioned, we are definitely not there yet. Another topic is that another danger is really to ignore requirements coming from the vertical side. I know it's quite hard to try to address these kind of service guarantees. It's a really different type of requirements, but still that is of utmost importance from vertical viewpoint. And if you're not able to address them, this will be a showstopper for using 5G technology or 5G-based network services for at least mission-critical industrial applications. And finally, of course, a third mistake would be to not permit through the net neutrality rules that kind of specialized services, kind of quality of service enabled services may be set up through our wide area networks, because if we don't have them, industrial applications will not be able to use these kind of networks. And now my view on 2022, I think, yes, there will be nailed down the technical basis for at least some service guarantees. And I think there is also a good chance to get a competitive price put down for 5G-based services. But definitely, I also think in 2022, we'll still be very far away from really having 5G being deployed on a ubiquitous basis. But that is also something we need to drive forward, because many of the applications, I talked about the smart grid and the rural areas, it's also in the transport area and so on, where we really need coverage on a quite global basis. Thank you very much.
Well, we thank you, Johannes, for the nice talk. So smart grids are also about networks, but networks with slightly different voltage levels than what we know from the telecom world, of course. So now we have touched three important verticals already. So automotive, energy, and industry. And of course, a fourth one should not be missed, which is health. And yeah, we will have a small introduction on the topic given by Christoph Tümmler from Napier University in Edinburgh and the Technical University of Munich in Germany. Christoph studied medicine, education, and political science at Heidelberg University, Germany, and completed a PhD thesis in the area of neurology. So quite a specialty probably in this room here. Christoph is one of the pioneers of e-health and has worked in different relevant topics such as tagging and tracking, RFID, the IoT and future networks since the late 90s. He has been advisor to the European Commission and the EU-China Roundtable on the IoT, and also serves as a convener of the health vertical of the European 5G Association. He's currently working on professional roles at Edinburgh Napier University and the Technical University of Munich. I mentioned this already, and now we are very excited to see your presentation, Christoph.
Thank you very much. Yeah, I think what is very important to understand before we go into the details of the 5G is the question, why is it so important to look into the healthcare domain in association with the 5G developments? I mean, 5G and the digital market is extremely important to the future, not only of Europe, but I can say that it is important to the future of every industrialized country. And I brought you a couple of figures just to highlight what actually healthcare means for different areas of the world. And in Europe, we have roughly around 10% of our GDP spent on healthcare. In America, it is roughly around 17.1%. These are a little bit older figures, so I would reckon this is a little bit higher now, but we're moving towards a mark of around 19% in 2020, 2022. In China, it's roughly 5.5% of the GDP, but if you think about the GDP of China, this means quite a lot. So the healthcare industry is very relevant to 5G as a market, as a domain, and obviously for all the verticals that are associated with that. And I mean, the market perspectives are incredible. Yeah? So the healthcare costs are outgrowing the GDP rise. That means, you know, healthcare costs globally rise much faster than the GDP. And also, you know, governments, they are ready to spend whatever is needed to finance the healthcare system. Now, I mean, it is clear that the healthcare system as we know it is not sustainable. So we have to think about measures to virtualize our healthcare system to make sure that the quality of care will stay the same. And this is a challenge which we will not manage without new technologies and digital tools. Well, you know, I'm not going into detail into the white papers that have been published on the 5G domain from different groups. But of course, you know, the aims and objectives are clear. We want to connect 1,000 times more devices per square meter or per space. We want to significantly improve the latency, the quality of service, the quality of experience. And the reason why that is because it will open the space for new technologies. If we are thinking about smart pharmaceuticals and individualized medicine, then we have to think about connecting far more devices to the networks than we do that today. Each asthma inhaler and each insulin pen is going to be a device in a network. And patients might use both. They might use 5 different asthma inhalers and 3 different insulin pens. So we have to think about people all of a sudden not only connect one smartphone, but a huge variety of devices in order to enable us to manage their care, in order to enable them to make proactive decisions in any kind of healthcare setup. And I brought you this just to talk a little bit about practical considerations. While I'm speaking, we are just about to set up a healthcare demonstrator in Munich at the Technical University, at the Klinikum Rechts der Isar, which is a teaching hospital. And we are thinking about these kind of architectures. This architecture is just where we stand at the moment, and we are looking into how things may fit together. We're looking into sliced networks. We are looking into edge clouds that are able to manage different services. Services such as individualized medicine, smart pharma, remote surgery, automated ordering and billing, and all of these things, they will all play a big role in the future of healthcare. I jump a couple of slides just to get a little bit ahead, you know, and you can see here that, you know, this is roughly how these considerations take shape. So basically, we are looking into implementations, companies that might contribute. We are thinking about different kind of technologies, and you can see that there is a lot of interest from different companies at different stages of this overall architecture, which have been articulated and which will go down in some kind of setup that we're going to establish starting in 2017. And you can see these are things that are already real. They cannot be implemented at the moment because our network technology simply don't provide the resources that are necessary. But in this picture, you see quite a lot. You get actually quite a glimpse of the future, because you see a nurse that is basically carrying a tag that uses a scanner to read a patient's identity, that is linked then to the medication that is dispensed by this perfusion pump that is actually linked with a chip to the network and so forth. So all of this technology is in principle there, but we cannot implement it at this point in time because 4G simply is not enough to enable this. And similar examples you can see in other vertical or shared parts of the healthcare vertical when we're, for example, talking about insulin pens, or if we're talking about asthma, smart inhalers. I'm working in Scotland, as was highlighted earlier on, and in Scotland we have a prevalence of asthma of 18.5% in the population, meaning 18.5% of the population are carrying asthma inhalers that are not connected to any network, where there is no documentation or real-time monitoring. And this is going to change that. Whereby the picture is a little bit misleading because the smartphone cannot manage 5, 4, or even 3 asthma inhalers with Bluetooth connectivity. We have a couple of challenges. We can discuss that later, so I will not go and speak about that in detail. But I think the message is clear. We will not be able to transform the healthcare system from an expert-based, hospital-based system to a distributed patient-centric care system without new communication technologies, new networks, and I'm very sure that 5G will transform healthcare as we know it into some kind of future model. Thank you very much.
Well, thank you also to you, Christoph. And now we immediately move on to the last presentation, and afterwards we'll enter the interactive mode. The last presentation will be given by Ioannis Kokliouros from OTE in Greece, who he's representing the network operators on this panel, also an important stakeholder, of course. Ioannis got a Master of Science degree from the Department of Electrical Engineering of Aristotle University of Thessaloniki in Greece, and a PhD degree from the University Pierre et Marie Curie in Paris, France. Since 1997, he has worked at the competition department and as an engineer consultant of the CTO of the Hellenic Telecommunications Organization, which is OTE. And since 2005, he is the head of OTE's research program section Fixed, and has been involved in different national, European, and international R&D projects and market-oriented activities, many of which have received international awards. So many thanks for coming, Ioannis, and we are looking forward to your presentation.
Many thanks, Andreas, for the invitation, because regarding the operator's point of view, it's very interesting to join actors from the wider market sector. My presentation, as you will find out, will be more technically oriented, actually coming from the results of an EU-funded project in the scope of the 5G PPP. So the aim here, as indicated, is just to discuss upon several options like SDN, NFV, and mobile edge computing that may be able to enhance and modify to the best the network architecture in the scope of the 5G forthcoming applications. And why to do so? The answer may come from this slide, which gives an option of what we actually perceive in our modern world. First of all, we have the option of the strong convergence between internet and communications networks on the one hand and the global IT world on the other. And this affects the way we work, the way we live, the way we enjoy. So it is essential in order to face the enormous and the multiple applications and challenges coming from the development of the technology within, let's say, the converged framework I mentioned earlier, to have the necessary network applications, the necessary network infrastructures that will provide the necessary opportunities for the end users and the market actors so that to be able to offer new services, new facilities, new products. And this is mentioned briefly in here. We expect that in the phase of the year 2020, normally we will have a multiplicity of heterogeneous network infrastructures that will be able to connect everything, so that to satisfy users, a multiplicity of equipment, things in the scope of the Internet of Things, goods, services, computer centers, knowledge, information and processes, and we must somehow find our way to the future. So the aim here is to discuss how to find solutions from my point in the scope of the networks that are to support the development, so that to improve the existing networks, to incorporate these innovative features that will be able to provide the opportunity for a better network management. Keep this, because this is very important and will be a critical issue for the discussion that will follow, and for the offering of new services. What kind of services? We will discuss this in this presentation and in the panel. And the aim here is not only to promote technical solutions, but also to assess business options, financial perspectives, regulatory views, the social implications, and so on. So the reply for all these issues potentially might be to find a way so that all involved market actors are to have a strong involvement in these processes. And the aim here is to create new opportunities for novelty and investments. The solution might be via the forthcoming fifth generation or 5G of telecom system. And these are some of the expected benefits that are to come. I will pass very quickly, for the sake of the economy of time, some of the activities towards that area, so that to see what is happening globally. First, I start by the ITU, the International Telecommunication Union. What are the initiatives are towards what we call 5G? We have the ITUR, which envisages several usage scenarios, application trends, etc., in parallel with the ITUT sector. And there are some initiatives in the way to identify the IMT 2020. Then I mention the very important activities taken place in the scope of 3G PP, where we have 3 phases of releases: the Technical Specification Group Radio Access Network, the Technical Specification Group Service and System Aspects, together with Service Aspects number 5, which identify in the scope of the 3G PP oriented in the mobile world, the progress performed. We have in the scope of the European Telecommunication Standards Institute, the NFB ISG group, the second phase, and the MEC ISG, which are also dealing with the option of promoting new solutions. And I also mentioned some activities at the case of IEEE and ONF, Open Networking Foundation, where in these cases both SDN and NFV are of prime importance. About regional initiatives, I start from Europe, the concept of the previous FP7 research activities, now partially covered in the scope of 5G by the 5G PPP initiative, which is a very important initiative supported by the European Commission and the public and private partners representing the European market. In the global arena, we have also the 5G Forum in Korea, which identifies some issues coming from the Internet of Things, cloud, big data, mobile fields. The same somehow takes place, in China, where we have the IMT 2020 initiative, which has some similarities in principle with the European ones. the 5G MF in Japan and the 5G Americas. To my personal understanding, most of the work actually takes place in Europe, China, and Korea, although in Japan and in the US we have some similar initiatives. About the industry alliances that may affect the progress in the area, I simply mentioned the next generation mobile networks, probably known to most of you, and the Small Cell Forum, which is very important in the scope of using small cells for the promotion of virtualization aspects via the implication of small cell technology for mass deployment in heterogeneous networks, and some very remarkable open source initiatives following to the requirements of the European Commission, like the OPNF, the OpenStack, very important, Open Daylight, and so on. The current status is given here. I don't want to insist more here. Just now try to pass very quickly in the scope of the 5G infrastructure. There are several KPIs already identified in the European stage by the 5G EEE initiative. What I want to discuss is this slide. First of all, as we face several challenges implicating for latency, resilience, coverage, and bandwidth in the scope of modern architecture related to the 5G architecture, we expect that 5G should be an evolution regarding at least the network part, as the network is to be transformed to an intelligent orchestration platform. And software-based system in this scope can offer a kind of strong flexibility, which is described very briefly here. To become more specific, first of all, we have the option of SDN, software-defined networking, which is quite beneficial for many reasons. Some are briefly mentioned here. I feel that these these techniques can lead to a sort of innovative network that will offer immense resources and support transport, routing, storage, and execution. This slide, just informative, coming from a report in 2013, gives an idea how operators, network operators, expect SDN to provide several benefits. For most cases, there are many expectations, and I feel that we are in a good way towards that. The second option is the inclusion of NFV, Network Functions Virtualization. For those probably not aware of the meaning of these terms, we have to understand that this permits virtualization of software-based network functions, and this could be beneficial for the reasons indicated here. That is, we can translate individual virtual network functions into software processes, and this can improve network scalability and reduce time to the market. I have deleted the previous references, which may be technical oriented, but for the market, this is very important in parallel with that. So why to bring these two together? Because we have advantages and benefits. It is possible to help the virtualization of the network infrastructure via SDN, and can have a better operation, administration, and management. And in parallel with that, we can have, via the NFV, rapid introduction of new functions and services, exploitation of existing virtualization and cloud management technologies. This can be offered together with cloud solutions, reduction of CapEx and OpEx, and many more. And via the mobile edge computing, if we bring all together, this is also an advantageous feature, as it gives the opportunity to promote aspects like proximity, location awareness, low latency, high bandwidth, as well as in parallel with other options like minimized data transit costs and so on. So these provide the opportunity to have better options, but still we have challenges as of the interconnection of the VNFs, the building up of a proper system where the NFV can be of critical importance, issues regarding integration, find the best placement of VNF, and so on. So I think that I have to finalize here my presentation. However, the fact is that regarding the technical point of view, together with other aspects like regulatory and financial, it is essential to enhance and modernize the existing network infrastructures because, as a previous speaker said, the network already exists. It's not something new. The way is to find solutions so that to improve the network performance, to improve the network management, so that to include new solutions. And this can be done in the scope of a global and converged world between communications and IT solutions via implementing smart tools like the ones I mentioned before, SDN, NFV, Cloud NFV, mobile edge computing, and so on. However, the challenge remains directly to the market actors. We will wait and see, but I'm quite optimistic for the future. In any case, thank you for your attention. I just tried to give an idea of these features relevant to the international standardization aspects, together with other initiatives. And thank you again for your attention and your patience, because I have the feeling that I overpassed my time.
Well, thank you, Johannes. It was just 1 minute overtime, so not a problem at all. So now we already heard something about possible building blocks for supporting vertical industries in an optimal way. We have heard about SDN, NFV, and also mobile edge computing. And I would agree that these are important technologies that we need for many different use cases and applications. So, and this finishes now the presentation part of this panel discussion. So we started with an asparagus sensor as the first possible use case. Then we heard something about industrial automation. We heard about car-to-car communication, car-to-infrastructure communication, about a smart grid, about many applications for health. And I think this gives a rather good overview of different use cases that people from vertical industries have in mind. I'm sure we haven't had the killer application that will come up because nobody knows that in advance, but this is something that time has to show, and the one who will be able to have it first, of course, will be the lucky one at the end. So, but anyway, so this is, that's it for the presentations, and now we enter the interactive modes. So, and I would say, first of all, we would like to give everybody in the audience the chance to ask any questions or give any comments. Are there any questions?
Thank you. As described in the presentations, there are a lot of vertical applications that have different requirements, different ecosystems. So how do these different industry work with the cellular industry to make sure that this 5G eventually will meet the requirement of all those different industries?
So is it a specific question to one of the panelists or a general question? A general question. So is anybody can give a quick answer? Yeah, maybe could you yourself repeat it again, please?
The question is, this vertical industries, they have different requirements, and some involve regulations, legal issues, something like that, And then how, there's a different requirement. How do this vertical industry work with the cellular industry to make sure the 5G, eventually will meet those requirements?
So I think the question is how the vertical industries collaborate with the telecom industry in order to enable all these use cases and make sure that they will become a success. So, Yannis.
Oh, okay. Although I'm coming from the pure network operators part of the market, as it is evident from this panel, which is a very interesting one, is the fact that we are facing a transformation of what we actually understand as network infrastructure, as equipment, as facilities, services offered, that is via the inclusion of a multiplicity of solutions and of new products in the market, in the telecoms market, which is strongly influenced by the IT market, it is essential that we must have for our works, for our way of living, for everything, more opportunities. So what I personally understand it as is the fact that because of these challenges, because of the fact that many sectors of the work of the market must find a way to get benefits the one to the other and create new solutions, new services, new products via the usage of modern technologies, I feel this is finally 5G. 5G is not a simple transition from the 4G of mobile communication to a next level. It's an extension which will cover the global market sector. To my understanding, this will create new opportunities for the market. This will help penetrate the new technologies or the way we handle the new technologies into other areas, potentially isolated, although not being isolated, as the previous before me speaker said, in the health area. But we are trying to find a way to bring them under a common scope. So I feel this will be the option coming for 5G.
But maybe just a follow-up question. So Yannis, what is OTE doing in a concrete way in order to assure that future networks will match
the... of the Deutsche Telekom group of companies. It's a network operator and telecoms provider, and we are following the development in the scope of the group we belong, because we live in a very competitive international market. We are facing the challenges. We are gradually implementing solutions like the ones I've mentioned, in order to enrich our network, to make our network more flexible, open, able to accept enormous amounts of data within, and able to support via investments we perform in selected domains of technologies, so that to serve our market needs. We face very carefully the challenge coming from 5G, because we feel that this will create new synergies with other areas like the automotive area, the energy area, the health area. We have representatives from these sectors, and this will lead to new products and facilities, potentially differentiated to what we actually perceive in our everyday life. So we invest in new technologies, and we are still investing and looking for new solutions.
Yeah, thank you. I think Linus wants to add something.
Yes, about requirements. So last year there was a couple of white papers that we produced from the vertical industries. I think it was 5 or 6 papers, and several of us were involved in that work. And that's one way I think that we have been working together to summarize and work on the requirements. And that has been further worked on during this year also, and presented in the Mobile World Congress, as far as I know, in February. So there is ongoing work. It could be, of course, continuing and better, but that was, I think, a good work there.
And maybe I can add a couple of words myself. So, I mean, the vertical industries are industries like industrial automation, the automotive business, and so on. And these are very conservative industries usually. So we have very long lifetimes of equipment in industrial automation, 10, 15, 20 years, cars, innovation cycles of 5 years, and so on. So, and this is very much different from the telecom industry. So with very much shorter innovation cycles. And therefore, I think it takes some time for the verticals to recognize the potential of 5G and so on. So that's also the case for my company, for Bosch, for example. But now we start to recognize the potential of 5G, and we get more and more open to also enter discussions with telecoms, with universities, with operators, and so on. And therefore, we are getting more and more open for these discussions. And of course, it would be good if also the telecom industry keeps on being interested in these discussions, and it's really what we need. And the white papers that Linus has mentioned certainly are one step in this direction. So to summarize points of view, requirements, applications, and so on. And this is just the beginning, of course. Yeah. All right, so any further question from the audience? So that's your unique chance to ask what you ever wanted to know. Didier?
Thanks. It's a very, very interesting panel, so thanks for this. One question referring to the white paper on vertical for the Mobile World Congress. You know, there were 25 use cases for the 5 vertical industry. If you consider de-risking 5G or making progress and experimenting and making some trials between vertical and the 5G development, do you think there should be experimentation on the different use cases, or do you see some priorities in order to really come closer between the vertical and the 5G development? Are there some priorities, or are all the use cases of, let's say, same level of priority?
Johannes?
I think it can be 2 types of trials and test scenarios, so to say. First step could be to do some testing whether the specific requirements and features what we have throughout many verticals can be fulfilled, thinking about the service guarantees. So how to make sure, or can we really make sure that the slices, for example, provide the right guarantees which are required for smart grid and for industry automation and so on. That can be even done without large infrastructures coming from the verticals. And in parallel, as you just mentioned, then of course also putting the 5G solutions together with the vertical technology to really make sure that the industrial applications are fine with the technology and the solutions which are provided by 5G. And I think in both kind of trials and test scenarios, we will gain further insights and we will be able to improve 5G technology step by step.
Christoph?
Yeah, maybe allow me one comment to that. You know, I think I support everything that Johannes said. This is absolutely correct. We see, or we of course have been thinking and considering about different scenarios, how innovation could take place in the 5G industry. And there were some people say, oh yeah, we have to go top down. There's all needs to be top down, and we tried this, and it was okay. And other people, they made a case for, let's do this bottom up. Everything should come from the vertical and go up. But I think the truth is probably somewhere in between. So we are looking at different projects in the verticals, in the 5G industry, and you can see, for example, the 5G PPP phase 1 was an example more where we put a focus on the industry to have a top-down approach, but at the same time we are discussing in the 5G action plan already more grassroots approaches, and I may be able to tell you that, you know, we will see from 2017 onwards these projects on local level, regional level, national level coming up, where there will be plenty of opportunity for verticals to get involved.
Johannes, short follow-up.
One other option coming directly from the market is the fact that 5G-related activities in the wider European market is a unique and much promising opportunity in the global telecommunications, IT, every kind of arena, because the fact is that we expect new services to raise, new kind of equipment, new facilities within an interconnected world. So all these should be beneficial in the European economy and will create new opportunities for investments, for working places compared to our international competitors like, for example, Japan, China, the US, and so on. I think 5G is a unique opportunity for the European Union following to the successful example of the 3G.
All right, so I would say let's make it a bit more specific. So we have many researchers here in the audience, of course, doing a great work, great job to make 5G become reality. We've heard from you something about use cases and requirements, except for Yannis, who has already mentioned several technologies. But what do you think, which building blocks are really the most critical ones for 5G? We have millimeter wave radio links, we have edge computing, we have SDN, NFV, device-to-device communication. So maybe you can just go through the panel here. So what do you think, what in your opinion are the top 3 building blocks that we need in order to make most use cases become reality? François, maybe if you could just start.
Sure. It's difficult to say which building block will be important. I think all are important for automotive because I said automotive is a completely different technology. It's not IT. We use IT to move forward safety, to get more comfort in the vehicle. What is important in 5G is the ability to get some sustainable development because the capacity of the 5G network to involve different radio technology will be key to launch investment and to ensure that whatever radio technology you use now, you will still in the future be able to be connected and continue to use the service. I think the obsolescence is a very important thread for the investment in automotive.
Yeah, I don't really care about how you do it, but I think that reliability is the most important attribute of 5G, that you need to improve that one. If you can manage to improve on reliability, then I think the rest will follow for many vertical applications.
So I'd like to agree to Linus. So I also don't really care on how these kind of communication solutions are built as long as they are fulfilling our needs, what we have from our applications. And what is really very important is, besides fulfilling the technical aspects, the technical requirements, also the ease of use. So to be sure that we, from a vertical perspective, don't need to deep dive into 5G technology to really use it, but just get the right interfaces, the right northbound interfaces, so to say, to simply use what's there and to simply ask for the service what we need.
Yeah, I think for the healthcare domain, I can say that definitely the edge cloud element is very important to us. And this results from the fact that obviously privacy and security, confidentiality is very important. And I cannot imagine that we are going to share huge amounts of data, keyword big data, with companies such as Google or IBM in an unsafe or insecure manner. We will not send huge amounts of confidential patient data for some kind of processing that takes place somewhere remotely in a public cloud. I cannot see that. Hence why I believe we need to look carefully at the end-to-end capabilities, and we have to look into processes that enable us to bring the software to the data rather than the data to the software.
Okay. I also share the views of the previous speakers. It's difficult to identify some criteria or some priorities because it depends on the area of the end client, if it is residential or business and so on. However, being in the same, let's say, direction with the previous speakers, I would like to say that as of me, I find that reliability, network reliability, and a proper service level agreement should be of prime importance, together, of course, with network openness and security issues. But I would, if it is to select one, I would select it reliability as well.
Okay, so as we see, so there was one concrete answer from Christoph regarding edge computing, which is certainly important. And then, as you can see, the vertical industries don't care so much how it is done, as long as it is done. So, and that's hopefully then what you can contribute to the whole topic and make enable a higher reliability and all the things that have been mentioned before. But yeah, maybe another question. So, do we really need 5G for most of these use cases? I mean, there are other technologies around. We have NB-IoT, which may be used for massive machine type communication. Edge computing, you can use also edge computing with LTE. We don't need 5G for that. We have ITS G5. We had a discussion on that during lunch with François already, which can also be used for car-to-car communication. So do we actually need 5G, or are the existing technologies maybe sufficient in many cases? Any volunteers for the answer? Johannes.
As I said before, it is the way how we assess the meaning 5G. For me, it is essential because 5G is not only a networking aspect, it's something more generalized. It could be said otherwise as a kind of conventions between IT, communications, bringing together services, equipment, everything technically supported within a fully interconnected world. So if somebody accepts this vision, I think that, and for me this is 5G, it's not a next generation of a protocol or something like that, it's a new reality. I think it is essential in order to realize interconnection between every device, every network, every facility.
Yeah, comment there, maybe, so what we have today at least, that's not enough. So looking into 4G, looking into 15.4 or 802.11, they don't deliver what we need to have the wireless solutions as we would like them to be, or our customers would like them to be. So there is for sure a gap, and if it's 5G or if it's something else, that might be a question, but I think 5G has a good opportunity to fill that hole.
Okay, so I don't see any other answers. So maybe question again to the audience. Are there any questions that have come up in the meantime? Yeah, there is one.
Hello. The question is, we all know the technology today, Wi-Fi, in the 5 gigahertz band. It's a band with a huge amount of spectrum, is underused, and it can used for short-range communications. A significant number of the examples given can be implemented in short-range private networks, such as a healthcare network inside the hospital or in industrial area, or the asparagus example that was given, or maybe a short-range communication between vehicles. So the question is, the technology is here. I mean, it can be optimized, of course. It can be more secure. The spectrum is there. It doesn't. Nobody uses it. So why do you think? I mean, tomorrow morning, somebody can say, okay, let's have a 4+ G, I don't know, based on 5 gigahertz Wi-Fi and implement many, many things. Why do you think this will not happen or is not happening? Thanks.
Thank you very much. So this goes in the same direction as my previous question, whether we really need 5G. Johannes, yeah.
I think 2 parts as an answer. First thing is, it's not ready to provide service guarantees, at least not in a scalable manner as such. You always have kind of a best effort behavior. So this is how the technology which is available so far in that area. And the second thing is, you will not be able to use it in each and every area, because we will need, and we need some long-range communication as well, together with service guarantees, and as well as for that, these techniques are not per se, or not as they are available today, really usable.
Any other opinion, Christoph?
I understand that you addressed the hospital setup directly, so this is why I want to give a quick answer on that. The problem we are having with Wi-Fi in the hospital scenario is that it is not easy to implement. So if you want to roll it out, you need some kind of construction measure, you need to deploy access points, you put wires in the wall and so forth. Many hospitals don't have that capability at this point in time, but they shy away of the construction work to do it and the cost to do it. And I think this is exactly where 5G, whatever that may be, comes into play, when we come up with plug-and-play solutions that work similar to telecommunication devices, where you don't need to basically put wires in the wall, where you don't need to screw access points to the wall, where you have better guarantee of service and all of these kind of things. So I think this is concretely where hospitals would prefer technology apart from wireless technology.
François?
Yeah, 5G is really absolutely necessary for automotive. So now future vehicle will use HD video as a key sensor to see the road. So you will replace a driver. So radar are not enough. You need also to see. And the transmission of video is seen as a huge opportunity to, for instance, when you are following a truck, the video from the truck in front of you will be used by the onboard computer to see what is in the front of you and not seen from your vehicle, and these are HD videos. So there is a need of transfer of huge amount of data, and you have not to forget that the mobility services are using a lot of data. We speak about big data in transport, meaning we need the right network to transfer this big data everywhere. We cannot rely on Wi-Fi. There is a need of wide deployment on roads, roads not being around population, so this can only be done through mobile network with operator. Maybe to come back to the first question as well, I think 5G is even the response to your question. So we need to create a network dedicated to certain services. So because in order to use efficiently communication, there is absolutely a need that the network is completely dedicated with feature answering the need of the services. And that's the answer provided by 5G with NFV, software-defined network, slicing, etc. So it's absolutely necessary to go forward.
Yeah, I think the automotive domain is also a bit special here because we really need wide area coverage for many use cases. So then the alternative would be to build up a new infrastructure from scratch, but it's maybe simply easier to reuse than what will be there anyway. And I mean, Christoph also brought up a very good point. So the question is, what is 5G? So if we are talking to operators, they tell us 5G will be anything. So it's not just a new radio interface, it's also the integration of Wi-Fi, of other technologies, and then everything that communicates may be 5G at the end. So that's at least what operators tell us. So we are already approaching the end. So, but there's another question here. Yeah, please.
Thank you. My question is related more to the business cases. So to which extent you see that public funding is going to boost the adoption of some verticals and some of the technology, and to which extent you see a return of investment only for private sector? So for example, hospital, we have heard that mainly the money from hospital is coming from the central government, so it's like a public funding. But do you see any use case in which the private sector will be able to self-sustain itself without the need for private funding?
Thank you. Christoph.
Maybe because you addressed the hospital, you know, so the thing is, I struggle a little bit to draw that dividing line between the private economy and the public economy, especially, you know, in a time where our central bank prints about 80 billion a month and so on, you know. So what I see is, as I pointed out in my presentation, is the potential. So basically, there's a lot of money in healthcare, and this money will be spent wherever it has the biggest impact and the biggest effect. And you can already now see things like, you know, the pharmaceutical companies that are thinking about fitting their pharmaceuticals with technologies that allow them to connect or to be hyper-connected. And this may be a narrowband IoT or any other technology that you might then summarize under this header 5G. And also basically as the care, the whole treatment of people is changing, and people are going to the hospital less and less, and we reduce the hospital beds. We have been reducing them for 20 years or 30 years. So we will treat people more in their own environment. But in order to do that, Data has to be transported, collected, analyzed, algorithms have to be run, and so forth. So I see, especially in the health domain, there is huge potential for private companies, SMEs, big industries, and so forth. And yes, the public funds, we would need much more than we have at the moment. Yeah? If we look at the potential and what is actually put in this at this point in time by the European Union, by the national governments, of course, it's by far not enough if we look to Asia, if we look to the US. Yeah? So in order to be competitive, we would need more engagement from public funds, we would need more engagement from big industries, and of course, the more money you make available now, the quicker the implementation.
Johannes.
To mention the following, as we are living in a competitive, let's say, market, where there are opportunities, for investment, for profit, there are interesting parties. That is in the scope of the European market. When via the intended, let's say, research activities for the implication of the new 5G based reality, we may be able to have new facilities that are to be offered via different channels, via different market sectors to the users, the residential users, the business users. This will create impact in the market, and I feel that the market itself is the one who will finally give the responses and the solution. Where we have innovation, where we have a successful offering of new service, which should be attractive either to the end user or to the business user, this kind of service will create a kind of impact, a kind of chaining reaction potentially. If it is successful, it will revive and create new channels in the market. If not, it will not be accepted by the market. I feel that the fact that we have many options like the Internet of Things, which is a very innovative one and still not properly investigated, which can be joined with IT and the communications network and support the inclusion of intelligence in our everyday life, and our everyday life is our home, our office, everything. I think this will give many opportunities. So my point of view is that 5G will create new channels, will support innovation, and via innovation, the market will find by itself the proper solutions for further innovation, for further activities, for further novelties. If something is to go wrong, then the market will delete it by itself.
So does this mean that you are saying that no more public funding is needed?
It depends, because I think that the question may have a political aspect. My feeling is that as the European Union is a liberalized market, my personal feeling, I think that the private sector should be the one who will give the final solutions everywhere. But this is my personal estimation and feeling.
Yeah, I mean, we have heard that there are different opinions on this topic, and of course, within the market will tell what will be successful at the end and what not, but it's also about competing with other markets, other regions on this earth, and their public funding, in my opinion at least, certainly may help to get a leading edge on 5G. All right, so any last question from the audience? If not, then I have a last question to the panelists. So now, I mean, this was a short panel, time really flew away, but what is your personal opinion? So when we will see the use cases that you've introduced at the beginning really become reality, we will have 5G first deployments in 2018, in 2020, in Tokyo then, but this will be the very first deployments, and then it will certainly take some time to realize the use cases and to have all the prerequisites available. So maybe we can just have the whole panel again giving a short statement. François, when do you think will 5G be ready for enabling autonomous driving and all these things that you introduced before?
It's rather really a long-term approach, because autonomous driving is just coming into the market, and there is a need to get stepwise, yeah, and to get some custom from the users and the OEMs about this technology. So we have rather to foresee 2030 as reasonable target for connected and automated driving. One small point as well, we did not mention ever, but for instance, my feeling is that 3G, 4G was defined for mobile phone and smartphone. I do not remember any deep discussion during the setup of LTE with other industry sectors and the communication sector, for instance. And for the first time, we have very deep and interactive discussion with different industry players around the communication network. So you have seen in many presentations not only smartphone or IP application, but you see real industrial application. And that's, I think that's a key of the success, because we see that 5G is in the mind of the whole telecommunication industry, defined to be serving the industry. And that's also for the industry very important. So we feel comfortable because you think about the industry first before thinking about your networks. That's very key. Yeah.
Okay, thank you, Linus.
Both in the power area and in the process automation area, I think there are already use cases and applications which would benefit from a robust communication, wireless communication system. So to some extent, I think that we are ready now. We have already customers waiting for you, so when you are ready, we are ready. There will for sure be more opportunities further on, but I think we already have at least a starting point to start to use your solutions.
I think so 5G will be kind of an evolution from today's technology really to some sort of new communication solutions, also fulfilling our vertical needs. And I expect that really latest by 2020 we will have some significant technical solutions as well as very first deployments there. Where these kind of solutions are used, and where they are used first, that depends very much on the domain you're looking at. So I think it's very urgent, and in some domains, for example, smart grid, so there you could deploy it today if it would be there, as I've explained in this backhaul medium voltage area. You also could deploy it if you look into the transport domain, also beside the automotive area, when I'm thinking about train control and all these kind of topics. There are other domains where it also will be very important, but where the application will be much later. And so from my opinion, for example, manufacturing is one of them, for which it's not most urgent, and it still will take some time. Also because of the much more stringent requirements what we have there compared to other domains again. So it's really this kind of question, when it will come for the vertical domains, it's very domain specific, and of course also technology dependent on when we will get which kind of 5G solution.
As I said already earlier on in the presentation, with regards to healthcare, I mean, healthcare has a strong ambition with regards to 5G. So healthcare organizations want to contribute proactively to the design of specifications, and they are experimenting with their requirements. And we have experimentation sites lined up, and these experimentations will start in 2017, and I would reckon that maybe by 2019, 2020, we can see something that is stabilizing, and we can see applications. Some of them are highlighted earlier on, which are already on the way to become 5G applications. But before we can get there, of course, it is very important to see how 5G itself will be defined, say in 3-4 years from now, and what then will be considered 5G. On the other hand, there is already collaborations, horizontal collaborations with healthcare providers in China, and we are trying to figure out what kind of commonalities can we identify here in order to make sure that our specifications and our requirements really are considered by the industry and by the telecom providers. And all of these activities and initiatives, I think they're very important, and
probably by 2018, we should have a pretty clear idea where that journey will lead us.
Okay, for the case of the network operators, I feel that strong and reliable operators like the DT group of companies invest in the market because via the investments come our strength. And via the innovation we bring into the market in order to support new options for services in our modernized network, this actually creates our strength in the market. I feel so that the reliable telecom operators like the DT Group do invest in the market, and via the investment, the reliable and extended investment in new technologies and services, comes the result that is the possibility to host new application and the view to modernize our world. So I feel that for most cases the network should be able to accommodate the new services. As the previous speaker said, it's not only an option coming from the network operator, it's only an option as of the intended support which must come by the other market actors. My feeling is that around 2020, maybe it should be 2022, I don't know. For some cases like e-health, we will have reliable results. We do progress well in the energy section. I think a very important challenge should be the one relevant to the automotive market, but for the latter one, we will see. For some cases, however, I think that the results and the difference of the reality at the year 2020 compared to today should be critical and very easily identifiable.
All right, so that means it's a little bit of a mixed picture. So early applications might be available in 2020 or even before that. So the question again is, what is 5G? And the really cutting edge applications like autonomous driving and so on supported by 5G may take a little bit more time. So the innovation pipeline is filled at least. We don't have to worry about not enough use cases and applications. And yeah, now we are already over time a bit, so sorry for that. And thanks for staying longer a bit. So this closes the panel discussion. I would like to really thank all the panelists again for coming here and for serving on the panel. And also thank you very much all in the audience here for attending the session. I hope you enjoyed it a bit. And of course, this can just be the starting point for these discussions that we need between the vertical industries and the telecom world. And I'm sure at least most of the panelists will also be available afterwards for some offline discussions to deep dive on some topics maybe. So thank you very much again and enjoy the rest of the conference.